just want to start by thanking the ASWF for setting these up. I know how much work goes into it, and I just hugely appreciate all the work that is done by the organization. Um, um, so let me get started if that's all working okay. Right, there we go. Okay, so my topic today is the ORI encoding guidelines. This is a sub-project of the ASWF Open Renew Initiative. So the overall umbrella project is covering everything from OpenRV to XStudio, and the encoding guidelines are really just trying to focus on how do we make sure that the media you're encoding for review is the best quality that you can get, that we're trying to avoid all the kind of many pitfalls that you can fall into. So the main topic that we're trying to cover is next-gen codecs for VFX. So trying to move away from H.264. And at the end, I'm also going to go into the overall encoding guidelines and also how a lot of the graphs that I'm showing, how those were developed, how the testing that I've done was developed using the test suites that we developed as part of the encoding guidelines. So starting with the next-gen codecs. What we're trying to look at is there something better than H.264? We all use H.264 a lot, and if not, we're using ProRes, and these codecs are pretty old. I mean, they're great. I mean, for what they're doing, they do a fantastic job. But given that a lot of like H.264 was largely developed in 2003 to between 2003 and 2005, it's quite amazing how good they are. Sorry, but surely there must be something better that's come along since then. And similarly for ProRes and DNX HD, they're developed around about 2000, 2008, and I think there are a number of options for improvements over them. So the kind of next gen codecs that came along is more in 2014, 2015. So the commercial replacement of H.264 is H.265, also known as HVC, and that was aiming to get like 25 to 50% better compression than H.264. Now, Google did not like the licensing fees associated with H.265 and had bought a company developing codecs, and that ended up turning into VP9. And that's very much trying to be comparable to H.265. And we'll get into a lot of like the nuances of that in a short while. And that VP9 turned into a much bigger consortium and came out with AV1 a few years later, and that has better compression again than H.265. They're even working on an AV2. For codec issues so the patent issues with H.264 are somewhat significant if you're starting to sell a large number of applications, or even if you're not trying to sell something, even if you're trying to give it away. If we start giving away more than 100,000 copies of something, then we will still have to be paying for every single copy for a patent license. And those patents aren't really don't really expire until 2027. I mean, definitely some of them are starting to expire, but the full expiration isn't until 2027. H.265 is even further out, and there are also similar issues with the AAC audio codec too. So these VP9 and AV1 codecs are definitely three great alternatives to the patent requirements, and they're all part of this Alliance for Open Media, which includes Netflix, Google, Amazon, and so on. And the goal is to try and make them open sourced and patent free. The patent free is a little bit kind of it depends who you ask. There is the two big issues out there are there's this thing known as defensive termination clause, which is starting to be fairly common. So like USD has it as well, and that essentially means if you sue us, then that free right to use that license expires. So, if you're a big conglomerate and you're using my codec and you sue me, then you can't use my codec. And similarly with USD and so on. There is this company called Sysvel who has tried to put together a patent pool which and is starting to ask for patents for patent licensing. AO Media says that the patents don't overlap and are totally you shouldn't need to have a patent. So they still claim it's that these codecs are patent free, and they've actually have a defense pool. So in case you are sued, they should be hopefully defending you. Now, I'm not a lawyer, so if this is you're in a big enough company where this is even a concern for you, you definitely should seek your own legal advice. So what are the gains? Why am I even trying to do this? I'm definitely a little bit self-interested in that. We're super interested in trying to get OpenRV and XStudio to a point that they're easily accessible to people maybe working from home that don't have the bandwidth to compile these applications from scratch. So, what is it that we can do to make those freely accessible to everybody and lower that barrier as much as possible? And similarly, I think that's also true for software vendors. Even it's heartbreaking to see tools like Maya, which can produce phenomenal results, and the codecs that are available for them on Windows is pretty much MJPEG, which is a rather sad codec at this point. So if we can encourage the software vendors to have to adopt more open source patent-free codecs, maybe those barriers and that availability to be able to use decent codecs across the board would become a lot more available. And lastly, a lot of the codecs that we typically use, we're just using them in 8-bit mode, and I'm really hoping I can convince you that 8-bit is something you don't need to do anymore. So this is like a feature comparison chart, and I'm really only going to go over two because the rest I'm going to go in more detail in a sec. The two big ones which on this chart, which I think are interesting, that I'm not going to go into more detail about, is the alpha channel. So VP8 and VP9 both can compress movies with an alpha channel. So for certain applications, like if you're trying to do if you wanted to play back movies inside your application and do that as a composite over maybe CG media, then that can be a big win for you. Otherwise, normally, if you're using H.264, you have to end up having a separate image just for the alpha channel. The other one, which I'm not going into much detail on, is the HDR support. H.264, I believe, does not support the PQ HDR. In terms of application support, VP9 already is somewhat supported by tools like Houdini and Touch Design, and similarly with AV1's, Houdini is also supporting AV1. And Autodesk also supports AV1, but does not currently support VP9. So I think one of the things we're missing from here is the tools for encoding for some of the commercial ones. I think what would be terrific is to start seeing tools like Nuke having more broader support for the encoding part as well. So these are the examples of the movies that I'm doing a lot of testing with. So Netflix has this excellent open content reference library, which has a number of great, the kind of worst types of things you can encode. So you'll see these references over and over again. So I've deliberately picked them because they're hard to encode for. So I strongly recommend if you're looking to pick a new format, do your own testing, because you may find that with your media, for like if you're doing animation content instead of live action, you may be able to use lower settings and still get excellent quality. And I'm also just going to not go into a lot of detail over like how I'm judging the quality. by overall for all the testing I've done, I'm pretty much relying on two parameters. One is the VMAF, which is a algorithm Netflix developed to judge the quality, the perceptual quality of a movie, and mostly you can then get away with, what Netflix is encoding to is something that's slightly lower quality. We're looking at something which is like a 98, 99% quality. You can see here like the VP9 encoding is quite a bit less than that. But if you actually look at the media, it's actually still pretty good. I'm also using this PSNR parameter as well, which is a good sort of more it's less forgiving in terms of like, are you as close as you can possibly get to the original? So between those two, I'm mostly looking for extremely high quality media. The main two things the graphs I'm going to show are these two graphs where you're seeing the different lots of media against the file size and different lots of media against encoding time. Because I think that in terms of a lot of us creating the media, that's mostly what we're going to focus on. So in this particular case, what you're seeing is the blue one is the H.264 encoder. So you can see already here that the H.264 is typically a bit larger. VP8 is definitely not compressing as well to get to the same quality. And again, I feel like if you were encoding like animated movies and so on, I think this ratio will get much higher, because I think you could get away with much lower quality settings. But you are doing it, there is a cost to that. So typically this is only a few extra seconds, but to get that extra compression, it's just taking a little bit longer, at least for 8-bit quality. Now, for 8-bit support, this is pretty wide. I think you're pretty familiar with that, including doing to higher YUV compression. So if you want to go to 444 on Chrome, you can do that. You can see for H.265, there's more limited support, but with VP9 and AV1, there's pretty strong support, on Chrome on all platforms. Similarly on Firefox. One which is for some reason is not good is this 422 on Chrome, where suddenly you've got some artifacts there. I see David's online. This was a showreel, a still from a showreel that David's got, which is a beautiful showreel, but it does have this great quantizing artifact. I'm not sure how well you're going to be able to see this in Zoom, but there is some banding that's happening here. In fact, if you zoom in on it, you can hopefully see the banding a little bit more. And this is a good example of the kind of quantizing that you can get. So typically when you're compressing an 8-bit movie, you don't even have 0 to 255 values. You really only have 220 values because of the video encoding. And that kind of squashing of your dynamic range is a lot of what's contributing to that banding. So if you jump to kind of like a 10 or 12-bit, and then you can start seeing smoother things. It doesn't mean it completely goes away, but it should be hugely lessened. Now, normally I would think that would come at a cost, but in fact, if you look here, that doesn't seem to actually happen. Even with H.264, it turns out that the 10-bit is actually smaller than the 8-bit, and that's pretty consistent. And you're seeing that also true that even like with VP9, even if you go to 12-bit, the difference between 10-bit and 12-bit is very slight. So you can get a lot more bits for your bytes without with only a little bit extra encoding time. Now for 10-bit support, it gets a little bit more hit and miss. You're starting to have different things dropping out on Safari and similarly with Firefox. Chrome is definitely still pretty terrific, especially with VP9 and AV1. You can pretty much play back anything so long as you can get you've got the throughput to your web browser. For efficiency, there's we've kind of gone over this graph, but you're definitely paying a little bit more in terms of encoding time. It turns out that actually H.264 doesn't those extra 10 bits do cost something more, but when you compare it to the SVT AV1 encoder, it can actually encode substantially faster than H.264. Similarly, like if you jump up to 422, you can, so here I'm actually starting to compare the encoded movies against ProRes and DNx HD. You can see fantastic compression ratios for a similar quality movie to ProRes and DNx HD. So if you've got a huge library of like, if you're making an animated movie, you want to keep all the reviews available online, that can save substantial amounts of storage space for you. Now, that is doing it at a cost. Your encoding times are starting to increase substantially. So this is going from taking a few seconds to 20 or 40 seconds, depending on which codec you're using. But it's still not, if something's taking a minute and your renders are taking hours, that's not like a huge cost necessarily, especially given the file savings that you ultimately get. So interframe encoding is so like particularly like if you're reviewing something in RV and you like scrubbing and you don't want to have any delay, and similarly like if you're trying to edit your movie together, you may be dropping into the middle of a QuickTime movie, you don't want to have what's called a large GOP, group of pictures. So, and the GOP is relates to how big the frames, all subsequent frames, you're actually looking at the differences between them. The encoder's looking at the differences between them, trying to work out how, like if a car is moving, can I just compress that car once and literally move it across the screen, and just record the differences. Now, with codecs like ProRes and DNx HD, there is none of that difference. And you can, with all these codecs, you can disable that interframe encoding. So that in theory makes the scrubbing faster. But it's doing it at a cost. So this graph is kind of showing you that like just even by having interframe encoding set to like 2 or 3, you're getting substantial file savings. I've been trying to come up with a graph that actually shows that what the kind of delay in scrubbing time is, and haven't quite come up with a good way of calculating that yet, but I'm still working on that. In my kind of personal, I just tried doing it just by feeling, and to me, when it loading up the same media that's generated here, I felt like a GOP of between 2 and 5 was actually fine. So actually that's right down in the bottom of this kind of curve down here. Now you'll see that also saves you from there are these weird spikes, particularly with VP9, where suddenly when you start going down to a GOP of 1, the encoding time goes through the roof. So setting it to 2 or 3, you're suddenly back at a much more reasonable encoding time. So definitely take a look at that, and I feel like, especially if you're playing back at 20, 24, 25 frames per second, I think you can get away with a non-1 GOP and still get terrific feedback. Just there's a couple more slides of just some of the more kind of crazy end of things you can get. This is comparing 12-bit encoding. So this is showing the DNx HD and comparing it to the VP9 and AOM encoding time. This lib AOM AV1 codec is terrific in terms of the number of options it gives you, but it's definitely it comes at a cost. In terms of it often is quite slow. So I strongly recommend you look at the encoding guidelines to make sure you're using the right the settings I'm recommending, because it's quite easy to end up with something which seemingly can take hours. But it's definitely possible to set up some parameters, particularly at 4K, where you can get some reasonable results. And a couple other kind of crazy ones are RGB encoding. I've definitely heard of studios, the conversion from RGB to YEV can be very problematic, and you can avoid it by simply encoding your movies as RGB. And this does work all the way through to certainly on Chrome on web browsers, but it is at a cost. So you'll see the jump from here to up here. That's literally just the cost of YEV is done for a reason, in that it does make the picture much easier to compress. So you're ending up with like twice the file size by switching to RGB, but you're avoiding all the downsides of that RGB to YEV conversion. And the most crazy one of all is lossless. It's saying lossless in quotes because, of course, by converting to YEV, you're certainly you're losing something, but it does mean that any kind of like weird artifacts from the encoder itself would be taken away. So if you've got like particularly noisy frames or something where it's just really abusing the codec, then this is at least giving you an option for that. And I want to give a shout out, sadly, for H.264, which actually is pretty phenomenal. That you can see like these are extremely fast encoding times, comparable to DNX HD. You know, it's pretty incredible how quickly you can encode with like certain combinations of settings. The VP9 isn't far behind, but it's you know, it's still pretty impressive what H.264 can do in that particular case. So I'm not an audio expert, so but I think it's still worth pointing out that you know, as I mentioned earlier, AAC is an issue. If you do have options for using Opus, I believe it's comparable in quality to AAC, and doesn't appear to have any kind of patent issues. MP3 also is very much available. Those patents have expired. The codecs, I'm kind of, there's a couple codecs I really wish would just disappear. MJPEG is probably top of the list. It's quite amazing that we're still seeing productions that are asking for MJPEG as deliverables. I definitely feel that any of these 10-bit codecs are vastly superior to that, and you know, and especially since you know we're using this as to shipping you know these files around, you know, having something which is much smaller, it's got to be a big win. And H.265, you know, it is, again, it's an excellent codec, but I truly believe that VP9 and AV1 offer very good alternatives. I don't see any reason that we should be requesting H.265 from vendors. So this is kind of a summary of you know, it's not just cut and dry. So like which codec to use when, encoder to use when. Sorry. So there's two major encoders that you can use for AV1. One's called SVT AV1, which is from Intel, and again is open source. It only encodes to YV 420, but can do 8-bit and 10-bit. And if you are able to use that, it's excellent. It's usually as good as or faster than H.264, but with better compression. If you need to get to higher bit depths or 422 or 444, then the A01 is the way to go. But you definitely want to be looking at what parameters you're using, because it can be very extremely slow. And VP9 definitely fills in a bunch of gaps, including, you know, the GPU is much more widely supported. So for certain situations, maybe preferable. And if you really have to, then VP8 is still a pretty great substitute for H.264, for 8-bit H.264. And changing gears a little bit, this is more, I'm still starting to do early research on this, but I'm very interested in this file container called MKV, which I've been ignoring for many years, but I'm realizing that it's capable of storing arbitrary key value metadata, and metadata is something which all of these movie file formats have been pretty terrible at. The MOV and MP4 at best has been able to do a comment field, and maybe you can pick up one or two other fields that you can dump metadata into, but you're not really supposed to be putting that in there. But MKV you can put anything into, and it also doesn't complain about having, you can pretty much stick any codec into it. So I definitely feel like that would be another great file format that we, as an industry, would be great if we adopted more widely, since that will give us better opportunities for having metadata that can show up during our reviews, or be sent to the clients for them to come up in their reviews. One other area that I would love to spend more time on is OpenJPEG 2000. I know there are a number of studios that use the Kakadu decompressor. what's been super interesting recently is there's this extension to JPEG 2000 called HTJ2K for high throughput JPEG 2000, which is supposed to be 10 times faster, which might make it a lot more comparable to Kakadu and make it viable for using JPEG 2000 much more widely in reviews. It's definitely usable today if you're just doing like HD content, but my hope is that we should be aiming for something which can do like 4K, potentially stereo 4K. So I think this HJ2K could be great for that. So in conclusion, I'm hoping I'm convincing you that VP9 and AV1 can offer significant file savings and are comparable to H.265 hopefully without many of the licensing issues. And I think there's a lot of cases where we can use them instead of ProRes and DNx HD for long-term library support and maintain a lot of the resolution and accuracy that you need for that. And wherever possible, let's try and avoid pushing vendors into having to buy particular patented codecs wherever possible. So I've shown a lot of graphs, and all of this information, as much as possible, I've been putting into these guidelines that are available on the SWF GitHub repo. And the tests that I've been doing are all based out of this test suite that was developed by Daniel Flenaheen. And you can see, like, this is a great example of just doing a simple wedge of different CRF values. So it's very easy to just set up some initial values and see, well, I'm going to change these other values. It may be changing codecs, or it may be changing, particular parameters. And then within the same configuration file, you can decide how I want to graph those results. So am I doing a bar graph or a line chart? It's very easy to set up a comparison, let the machine go, and then you can come back and see the results. And there's web pages which also show you like the actual imagery and what the differences are in certain cases. We've also developed Docker containers. So if you want to, if you're having problems building FFmpeg from scratch with all the other parts, this is a good way to at least give you a guideline as to what parameters you need and how you build all the libraries that are feeding into the FFmpeg build. This is the URL to the encoding guidelines. If you haven't already joined the Slack channel, I strongly recommend doing so. It's a terrific forum, a way of meeting many of the experts in the field in lots of different areas, including this one. I can't tell you how much of this information has come from expertise from other studios and how much that's improved the overall result. That's it. I'll leave it on that, but I'm open to Q&A. We can maybe unmute Eric into these results. I don't understand your question, Eric. Do you want to unmute?
So VMAF in the past, I don't know how long, has rolled out an additional metric called CAMBI, C-A-M-B-I.
Oh, right.
And that, yeah, and so that, I can't remember exactly how it's set up. You may be able to have it be sort of added into your VMAF score, or I think you can have it reported as a separate score. And that looks for artifacting, and most specifically, I think it looks at banding. And
that's terrific.
Yeah, so there's some kind of newer features in VMAF. I don't know when these VMAF scores were generated, but there's some newer stuff that's come up that might be pretty neat to take a look at.
So yeah, I'm definitely generating these fairly recently. I'm using VMAF 3.0, but I was not using I wasn't using those particular parameters. So Jeff is asking about MXF versus NKV. I think MXF. I keep hearing horror stories on MXF container libraries that there aren't a lot of good ones out there. I know that certainly the camera manufacturers are very much going to be sticking with MXF, and I think particularly for um, metadata that's changing, MXF, I'm thinking, is probably the way to go. The MKV is really just for key value pairs. But in terms of content that can at least play back in web browsers, I think MKV is the way to go. Any other questions? No? Okay. Maybe we'll leave it there. Thank you very much, everyone.